Okay, hi everyone. I'm Ishan Anand. You can reach me on Twitter at IANAND, and welcome to the best of both worlds, Incremental Static Generation, or ISG, for Nuxt.js. So let's get started. There we go. Here's what we're going to cover. We're going to talk about what the heck is ISG and why should you care? And then we'll walk through what it takes to implement an ISG-inspired like flow in Nuxt.js. Now, a little warning, I'm actually more of a React and Next developer by background, which is actually one of the reasons I'm so excited to bring this over to the Nuxt ecosystem, where ISG hasn't really been as prominent. But a lot of the work I'm going to show you today is the work of these gentlemen. So hats off to them, and I'm really presenting their work on their behalf. You can find us around the web. We run a performance newsletter called Core Web Vitals Newsletter. A podcast about front-end and full-stack development you can find on javascriptjam.com. We also are core contributors to an open-source e-commerce framework. And then you can find us on Clubhouse. Just open the Clubhouse app every Thursday, noon Pacific time, lunchtime every Thursday, and search for JavaScript Thursdays, and you can find us. It's kind of an open mic night about JavaScript and web dev. And we are from Layer Zero. Layer Zero is a Jamstack platform bringing the benefits of fast sites and simple developer workflow, but for large, complex sites where traditional static techniques don't apply. And folks like these guys that have tens of thousands, hundreds of thousands, even millions of pages that they need to deliver, but they want those static-like developer experience in delivering them. And they get to use, all the same frameworks you're very familiar with, including Nuxt.js and Vue-based frameworks like Vue Storefront. Okay, so let's talk about what ISG is and why you should care about it. So it really all starts when you're, setting up your Nuxt project, and you have to make this decision in your config about, are you going to set the target to be static? So those pages are rendered statically at build time. This is sometimes called Jamstack. Or are they going to be rendered dynamically by server-side code? And this is when you set the target to server. And there's kind of a bit of a trade-off here. There's a attraction towards the static way of doing things for two reasons. One is really fast performance. Static sites are written in a way such that they can be stored on a CDN and served up very, very quickly from geographic points of presence all around the world. So it becomes a really fast experience for users. And then for the developer, traffic scalability kind of gets built in because all the content, as much as possible, is being served from the CDN. So you don't have to worry about DevOps and scaling up and down servers. So it looks very attractive at first glance. But part of the problem is that static sites add a new scaling dimension, which is as the number of pages on the site or the frequency of change increases, you run into more and more issues with the build time, either slowing the team down or just simply taking too long. So when you're working on a site that has, say, a personal blog or an e-commerce site that doesn't have a lot of posts, maybe 100 or less or 1,000 or less, then you're in kind of the static sweet spot. But if you got a large number of pages or frequent updates, it starts to become an issue. And, this kind of scale does happen. In fact, it's happening on the largest websites on the internet, and they really power the digital economy. So take, for example, in e-commerce, most online stores tend to have tens of thousands of products at a minimum. I've got here on the left some commerce examples. I'm using the number of SKUs or products as a proxy for the number of pages. But if you look at, say, a retail grocery store that has 60,000 SKUs, that's more than a typical static site in terms of number of pages. In fact, if you're at the Headless Commerce Summit last year, there was a survey, and the majority of folks were doing sites that had 10,000, even less than 1,000 pages. But here, if we can't take a physical store and map it to the digital realm with this technology, then we're really in trouble and try to scaling it for the web. And lots of folks think millions of pages is, well, only if you're Amazon. It happens more often than you think. Here, for example, a B2B forklift parts company has 8 million SKUs. That's a lot of pages. And then on the content side, you've got, folks like these guys at the top end of the market. They're pushing 80,000 stories per year, let alone their archives. So that's a lot of pages that would potentially need to be rebuilt. And then when you're operating at this kind of scale, you want to have techniques like A/B testing and personalization, which just add additional level of complexity. And you might have frequent updates. So, if you're a large e-commerce site, you've got folks who are merchandisers. Their whole job is moving products in and out of categories, changing copy, and there are multiple of them, changing your site multiple times a day. So you get these frequent changes across lots of pages, and that build friction can really build up. So there's a couple solutions that have evolved to solve build friction. I break them down into static and dynamic techniques. ISG is one of the dynamic techniques, but it's helpful to go through the static techniques because sometimes they do apply before you really get to those large scale. So the first thing you'd want to do is probably just to optimize build times. Just make the builds faster so they're less of an issue. So you can save your build artifacts, for example, and only regenerate what's changed. And the good news here is most platforms will cache, say, your node modules to improve build times between subsequent rebuilds. And as of Nuxt 2.14, it'll actually automatically optimize content-only rebuilds. So if the code hasn't changed and only the content has changed, those builds are going to be faster. But at very, very large scale, you still run into issues of potential excess cost and friction. To make this concrete, imagine you're a site that has 100,000 pages, and maybe with all the people changing it, there's at least a change every hour. In that 1 hour time span, it's unlikely traffic has visited all 100,000 pages. But every single deploy, you're regenerating all 100,000 pages. That not only adds to your build time, it's actually creating CPU cost in that build time that you're paying for. So with a really large site, this can actually add up and cut cost as well as friction for your team. Another technique to solve this is sharding. And that's where you split the site into smaller subsites that rebuild independently. So here, for example, imagine an e-commerce site where there's a blog and a e-commerce component under /shop. And what you do is have your CDN that maps the subdomains or paths to independent static Nuxt projects that can then build independently and hopefully do it faster. This can work, but it does create some headaches. So first off, it requires a CDN. And if you're going to actually try and test this end-to-end in staging or local development, you need either a CDN or CDN-like server to simulate stitching those two projects together. Then there's the issues of synchronizing cross-project code. You want to maintain the same theme, header and footer across both these projects so it feels like a unified site. So this creates a lot of additional maintenance overhead. And if you're a very large site, there's really a limit at which this can work, because to create a really fast individual shard, you might have an unwieldy number of shards you'd need to break a very, very large site in that has, say, hundred thousands of pages. Another technique is client-side rendering, or in the Nuxt world, I believe you guys call this very often SPA fallback. And this would be you take a section of your site, in this case, say the product routes, and you can see kind of the Nuxt config here where you basically just say exclude after saying target static, and then in the generate property, you specify the path, in this case /product, and then a fallback page that they're all going to load to, in this case fallback page.html. And that page will then fetch and render the page content once it loads in the browser. But if it's served up to a bot or other machine, it's basically always the same page. And that's kind of the challenge here. When it's always the same page, that means that there's potential negative impact to SEO, because not all bots can read JavaScript. Google can, but other bots, especially in social media, cannot. So those previews, when maybe you send a link to somebody, tend to look in not quite the content you intended. And it can hurt your performance because the page has to do more work before the user can see stuff, and that'll slow down the page. And then that takes us to incremental static generation. So ISG was a technique created by the folks at the React framework Nuxt.js in around April of 2020. And what it does is it generates new static pages on demand in response to incoming traffic. So this is kind of the best of both worlds, because it only builds the pages you need. And then after the first visit, all subsequent visit to any previously built page is really, really fast. You get the static-like page loads. Now, the challenge with ISG is it's actually a feature of both your infrastructure and your framework. So you need a kind of very deep integration up and down through multiple layers of the stack in order to get it. And so as a result, it's only been limited to Next.js, and only Next.js when running on certain platforms. Layer 0 is one of those, but you can't just take Next.js on every platform and just get ISG out of the box. So let me walk through how ISG works, at least from the user perspective. And there's two flavors to ISG. There's a fallback parameter, and when that fallback parameter is either set to true or blocking, the behavior is subtly different. So let's talk through the fallback true case. So in this case, a user has requested a page, and this is the static tweet demo the Nuxt team put out when they unveiled ISG. And its job is to basically just statically generate tweets. And they obviously can't generate every single tweet. That'd be too many pages. But this uses ISG to generate essentially every tweet that anyone comes to visit for. So if a user requests a tweet that they haven't rendered yet, the CDN quickly returns a fallback page with just the skeleton placeholder data. And then while that's being displayed to the user, this fallback page is fetching the JSON data, and the build process for this page is actually being run in the background. And when that JSON data is finished, the page gets rendered, but now any subsequent visit will also just get the full HTML version of the page, server-side rendered with no waiting. So that's the static type performance in every subsequent visit. Fallback blocking is now the preferred method. They unveiled it a little later. And the difference with fallback blocking is when a user requests a page that hasn't been visited, the browser just basically waits for the generated response. And the reason they did this is because of a lot of bots that had challenges dealing with JavaScript on the page with this placeholder and then loading the appropriate content. But just like with fallback true, any future visits get the statically built page with no waiting, and you get those really fast time to first byte times. Finally, before we move on, there's another technique called parallel static rendering. And in this technique, what you do is you basically allow the system to serve the pages dynamically. And then at deploy time, the system will analyze the traffic logs and decide what are the most high traffic pages, and it will fetch and render those ones asynchronously after the deploy. So you have a deploy, and then it goes through and says, let me make sure I render all the most important ones. If something comes in that's not one of those, you still just render that on demand. And this effectively decouples the build time from the deploy time. So you get immediate deploys while maximizing cache hits. So here's an example of that. You can see this middle bar that's moving across the screen. This is immediately after a deploy. It's actually rendering either the 100 most popular pages or whatever the developer has specified in this example needs to be rendered asynchronously after the deploy. Okay, so now let's talk about implementing ISG in Nuxt. And I've put ISG in quotes because it's not entirely the same as the ISG, but it's a very ISG-inspired flow. Let me actually just walk you through live what this looks like. So, you know, the Nuxt team did a Twitter example. We've decided to do a Medium example. So the way this works is it'll list out the authors, the blog posts for any author in Medium. So let me just pick this user. I'll go here, open my network tab. And we're going to share the source code for this so you can see how to implement it yourself. And then if I hit this, you'll see that loading indicator that the user got, and then we get the recent stories that have been written by that author. And you'll notice here is that request. This is the API response that returns essentially the JSON data that is that list of stories. You'll notice there's this other request. I'm going to get to that in a second, what that does. But let me clear this out and then show you this. If I load it, you'll see that loaded very fast. You did not see that placeholder. And in fact, you can see that unlike the original page you looked at, this one now has in the HTML content is the actual stories. So it's going to load that content really fast. Bots will be able to parse it. And in fact, if you look at the timing, our platform does report timing information that you can see right here in the browser. You can see it's actually a hit. In fact, it came back at about 40 milliseconds. So it's very extremely fast for anybody who's going to visit this page after this. So let's go back here and go to present. There we go. Okay, so just to recap the flow we just went through, user lands on the homepage, they enter an author's name, they get this loading screen, the JSON data is fetched for that author's blog posts, then they get listed out, and then the page gets rendered, and then behind the scenes, we're actually going to fetch the page again, and this is going to be for the SSR version of the page that had it rendered. We're going to essentially, from the client side, kick the server and say, hey, render the other version of this page, so that any subsequent visit will get an already built page, as you saw, with no waiting. If they had visited first direct page load, it's going to behave like fallback blocking, where it would have just waited for that response, but any future visits would get the full HTML page. Okay, let's talk about what it takes to implement ISG on Nuxt. And at this point, it's kind of a batteries not included situation. And that's because, as I mentioned earlier, ISG is a property of both your framework and your infrastructure. And so you need that deep integration across the stack. It doesn't really exist out of the box, so you have to add it in. So that means adding logic that's not already pre-built into Nuxt that would normally be there in the case of something like Next. And then you need logic at the edge that can detect when content hasn't been rendered yet, route it appropriately, and then cache or store those responses and serve them up depending on whether it's the first visit or not to that page. So as a result, every implementation in the Nuxt ecosystem of ISG is going to be app and infrastructure specific, because there's no established standards, especially at the edge logic layer, at least yet. Some folks are working on it. So for the purposes of today's demo, we're doing this on Nuxt 2.15, and we're going to use layer 0 Edge.js, which is our edge orchestration, but the same principles you should be able to extrapolate and apply to any other architecture. So let's talk about those two parts, configuring the edge and configuring the Nuxt app. So configuring the edge, we basically just need the simple property in the edge logic that detects if a page was previously rendered, and if it is, then wait for the response, and if it has already been rendered, then just send the rendered page immediately. And in fact, in layer 0 Edge.js, we have a single command for this. Edge.js in layer 0 is really our DSL for controlling the edge, right in JavaScript that runs inside your app code. And there's one command called onNotFound. When we implemented ISG for Next, we wanted to do this in a framework agnostic way. So we exposed this command so any framework could use it. The rest of kind of Edge.js should be self-explanatory. Here's an example of what it would look like. Basically, we're saying for this specific path, this is the /blogs username. We're able to set how long those ISG pages last. And then we say here, if the static page isn't found, then go to the app and actually render it out. And there's that onNotFound command. And then the second thing we need to do is configure the app. So there are three things we have to do here. First is we need to make sure we're using dynamic routes for the user. That's fairly standard, but I'll go through that in a second. Then we need to make sure we set up a REST API to power fetching the data from Medium so we can show the stories by that user. And then finally, we need to do that HTML fetch at the end so that we can populate the server-side rendered version of the page so that direct access will always be fast. So setting up dynamic page routes, fairly standard in Nuxt. Here's when you go through the source code, you can see in the /blogs_slug view, we're going to use async data to fetch the user's stories from the API routes. This is actually a sample code. It's not quite exactly the code that you'll see in the example that we'll send, but it's very, very close. And then for the REST API route, what you want to do, and this is in /API blogs.js, we're going to use Express to fetch the data from Medium for that user's feed, then parse it and deliver the results back. And then we need to serve that REST API route using Nuxt middleware custom API endpoint, which you can read in the documentation, but this is the fairly standard way to do it. And then finally, inside _slug.view, we need to make sure that we fetch the HTML version of the page at the very end of the process. And that way, both client-side and server-side transitions to the page will be very fast after that first visit. And the way we do this is basically onMount will fetch back to ourselves, and that'll tell the system, oh, there's a visit to this page, and it will go and render that HTML version of the page so that any visit there will also be fast. Okay, so we're going to share the code out, but there's some possible enhancements and future directions that we left out just to keep things simple. One enhancement here is supporting the fallback true flow, that is having that placeholder kind of skeleton if a user's navigating to it directly for the first time. You can actually do that in Edge.js. It's another command you'll need to use called loading page. And if you go through our documentation, you can see how that works. Use a combination of loading page and on not found in Edge.js to orchestrate that together. Another thing is the ability to do an intelligent fallback determined by bot or not bot. So I'm not aware of other platforms that can do this, but if you recall back, the reason that fallback blocking became the preferred is that bots can't read that data. But what's better for users is the fallback true with the JavaScript placeholder. Well, what you can do in Edge.js is you can conditionalize by whether the incoming request is a bot or not, and then you can actually take the appropriate action and serve up users just the placeholder text. And then for bots, you just send them only the server-side version of it. And one thing that would be great that you can do in Next that would be a nice enhancement to this is mixing static and dynamic in the same project. So it's not an all or nothing in the target. So in terms of future directions, we'd love to work with the community on standardizing this in the Nuxt framework, so it's a lot more portable and easier for folks to use without having to add it directly into their app. So if you're interested in that, feel free to reach out to us, and we'd love to collaborate. Finally, you can go try this out. You don't have to take my word for it. You can try the demo. You can view the source code, and you can deploy it for free by just going to try.layer0.co/Nuxt-Nation.
But yeah, make sure to
thank you.